Good afternoon, folks. We'd like to introduce you to the basics of SRE today, at least how we do this at Google. So, reliability. Obviously, it's important to us. A lot of things keep us up at night. We want to make sure that we don't have outages because of lack of power. We want to make sure that a bad code release doesn't completely stop us in our tracks. We want to make sure that we don't lose a bunch of customers during Black Friday because we have gotten overloaded and cannot serve capacity, and just latency goes flat and nobody gets responses. So at Google, we approach this with the establishment of the Site Reliability Engineering Group. And who are we to talk to you about this? I'm Jess Frame. I've been at Google for a bit over a decade, half as a developer, half as a SRE, working in platforms and cloud and social and a few other groups. In cloud, I've actually worked on App Engine networking and the Customer Reliability Engineering Group I'm with right now, which you'll hear more about later.
Hi, I'm Wallace. I'm a cloud consultant with professional services at Google. I've been at Google a little less than a year, and prior to Google, I spent 14 years at Nike in various operations, engineering, and architecture roles. So today, we're going to talk about 5 key areas. First, we're going to talk about the core problems that SRE solves. Second, we're going to talk about the key principles SRE uses to keep systems appropriately reliable. Then we'll dive into the responsibility and expertise that SREs have. Fourth, we'll kind of pull all this together and talk about how you can adopt some of the SRE practices within your organization. And then lastly, we'll talk about how Google could help you with this. So let's go ahead and get started in talking about what SRE is. But first, let's talk about what makes us unreliable and how SRE helps to solve these things. I'm going to see if this thing works. Ah, perfect. So, oops, we went back. It's skipping. Sorry about that. OK, here we go. So traditionally, product development teams or engineering teams spend a lot of their time designing, developing new features for projects and applications. But once those are ready to go into production, those teams typically move on to the next thing. And really, the majority of the total cost of ownership of software is after it's in production. So if you think of 1 month of development time is really equal to 10 months of production support. So if these engineering teams aren't managing the software once it's in production, who is? I'm not going to use this clicker. Sorry about that. All right. So again, we have the developers who are working on the new features. And once those are ready to go into production, they kind of throw it over the proverbial wall to the operations team. And the operations team, they deploy it into production, but more than deploying it in production, they're the team that's responsible for the reliability, scalability, and maintenance of the software. And more than just the software, it's the servers and services and infrastructure the software is running on. And in my experience, there's a lot more emphasis put on hiring for the development teams and the operations team. So you get a lot more features going over to the operations team, and the operations team can't juggle everything that's going on. It causes a lot of friction between these teams, and it's just not scalable. It's kind of a fragile model here. OK. So reducing the product lifecycle friction. So a lot of these, so we start with the business. The business or product management teams are the ones that make these feature requests that then go to the development teams. Development teams then implement these features, which then gets handed off to the operations team. So you have these barriers between these teams, a lot of friction. So we have Agile, the Agile methodology that breaks down the barrier between the business and development teams, but it doesn't really help with the barriers between the development operations team. So this is where DevOps comes in. So we think of DevOps really in 5 key areas. First, we want to break down that wall. This helps with the collaboration and velocity between the development and operation team. Second, we know things are going to break. We plan for that. We accept failure as normal. 2, smaller changes are easy to implement and deploy, which also makes them easier to roll back, which helps us with the mean time to recovery. 4, we want to remove human error from the equation wherever possible, and we do this leveraging tooling and automation. And 5th, we want to measure everything, because measurement is critical to determine success, especially these first 4 areas. So the SRE approach to operations. We SRE like to treat operations as an engineering problem. We hire people who don't want to do repetitive work, and we'll create automated solutions. We use data to guide decisions and help prioritize what we're going to work on next. Go to the next slide. So what do SRE teams at Google do? The SRE teams are not simply just engineers who carry the pagers. SRE folks are systems engineers who develop solutions and manage large distributed complex systems at scale. The SRE teams at Google have a saying where they like to automate this year's job away because there are more interesting problems to solve the next year. So if we think of DevOps as a programming interface, then SRE or class SRE implements DevOps. DevOps is really a cultural practice that breaks down the silos between not just the operations and engineering teams, but your network teams, your security team, architecture teams. And site reliability engineering is a set of those practices we've found to work and a job role. So now I'm going to hand this over to Jess to talk a little bit about the key principles of SRE.
Cool.
Is that working?
Nope, mine is also doing doubles, so.
Okay, sweet.
Have fun. So, much of the feedback loops that drive our paradigm have to do with the error budget, and we don't expect you to know what this means at all right now. So we want to, from the ground up, establish the significance of this with you and how we came to this conclusion. So first of all, our goal is reliability. We need to go through and determine how we measure this. The user is the most important feature in all this. So the naive approach doesn't always work for, depending on your service, depending on how it's distributed. Good minutes and total minutes was historically a very common thing, but this may actually not be a good representation of user happiness. So instead, we like to step back, ask you all to step back and think how the users are interacting with the system, and instead figure out what the interaction measurement is, instead, whether that's queries or uptime ping or other things if you're more of an MMO. But
They go too fast.
So, yes. So this moves the whole focal point of the success measurement away from the underlying individual machines and code and off to what the user actually sees. And we all know whatever we measure is what ends up being optimized for. So making sure this measurement is done well is the most important thing. So reliability is often presented as a goal of 9s. You've probably seen this thing before. Honestly, it looks big and scary, particularly when you get up to 3 9s being 9 hours of outage a year. But even at Google for a measurement, 5 9s is only maintained by a small number of teams. This is partly because it takes a lot of money to achieve that, so the underlying infrastructure is the most important thing to get moving with that. But also, honestly, your individual services, the reliability of your ISPs and cellular networks and everything else often will hit before that, and people can't tell the difference. So what about 100%? Really, the world is not about 100%. It is, nothing is certain. Our advice from running years and years of large-scale services is it's not worth the money. It's near impossible. Even if we as humanity had the technology, it comes at a hefty price. It comes at very slow change and features. That's not something we want. And each of those 9s is really an exponential cost. It's not linear. You can spend all of the money in the world trying to make something just count a number and not fail ever. So we were talking about availability. Our SLO, our service level objective, is actually what we term this internally. It is our goal. The main consequence for this is shame internally, because we have high standards for ourselves. The indicators are the metrics and other signals that we use to measure this and display it on graphs and do the quarterly reports. The agreements, the SLAs, end up being what's often shared with external customers, and the consequences of that with legal teams involved tends to be money. So again, focusing on user happiness, getting a good SLO is not as easy as it seems, but the most important thing to start with is keep it simple, and you will iterate through and get something more and more solid. Without backing data, it's you revise, you learn. That's the only way to go forward with it. For example, it may be unintuitive that you can set a low SLO and achieve it every day, but if the user expects higher of you, you will get complaints before your pager goes off, and that is a very large issue. So vital to the SRE approach here is that we get these three groups in agreement. It's not going to be easy, but it is. Without these three being on the same reliability goal and with the promise to support and defend each person that's trying to maintain that, we can't move forward. If we don't have agreement, if we don't have support, it doesn't matter if we're handed the keys to the system. We won't be able to work on it properly. It's hard to get this agreement, but there's luckily a few tools that can be used with this. One is pointing out the exponential cost to the business people. If they want 100%, that's going to be very, very expensive, and chances are they don't want to spend the money on it. There's a trade-off between reliability and speed with the developers, and they probably want to move fast. And in all of this system, the users will push back with unhappiness if it is not reliable enough, and they will go elsewhere. So this whole system will iterate, but you can get there. So having decided on a target and going through how we measure it and having an agreement between the three groups, we're going to go back to the error budget, which really is the reverse of the availability target. And what this is how much time you can be down and how many requests you can fail in order to further getting releases out, faster change progress, all of that, because we want to build things. We don't actually want to say no to you, ever. We have common goals here. So the error budgets, luckily, make this nice feedback loop of having shared goals, so we have less conflict and less churn. We're all on the same team here. We all want a successful product, no matter how much the ops people look like the bad people to say, no, we've had too much downtime. You need to cut off and not do any more releases. The developers and others eventually learn that this is all for the good of all of us. This whole thing encourages more responsible expectations and velocity as well from the various teams. So we were going over the DevOps principles earlier. This is kind of how the error budget paradigm fits within them. So you get the ownership of the silos, you get the error budgets themselves, which quantify it, which is vital, and how you measure the reliability is very important. So the concepts of SLO and error budget are all well and good, but what do we actually look like day to day as our job? We're going to go over our areas of expertise here, although where the lines are drawn vary from company to company. I've seen a bit of variety there. So most of those are pretty obvious. Metrics are common, capacity is necessary, helping with the change management. Emergency response is kind of our bread and butter, but culture is one of the interesting ones that isn't always pointed out, but is actually the most vital, and everybody is responsible for it. It's not just the SREs. Without the culture being supported by the business and developers, it's hard to continue. So, monitoring, alerting, pretty basic. We do suggest 2 different priorities, paging and tickets, depending on how bad the system is hurt right now, or if it's impending, to avoid in the future. And the most scary thing in the world right there is noisy, urgent alerts. That is what will burn out your people. This is what will end up with your system not getting the attention that it needs. There's a relevant story here about crying wolf, but still I see this pattern a lot of just a whole bunch of little alerts that are treated urgent and the same level as the whole system being down. So obviously to serve traffic, it's going to take some resources. And one's either going to have to solve this with planning your resources over time, auto-scaling, or just having absurd amounts of capacity in case you have large spikes to avoid outages. The last option definitely does not become a possibility the larger you grow, though, and that planning becomes more and more vital at that point. Even if money isn't an issue, tracking on the resources is absolutely vital, so you can see when something happens, if it is a feature that you want launched and you're acknowledging that that was a cost you had to it, or if this is a bug that's just going to get worse and worse, say a memory leak. Different teams handle this differently. We prescribe by roll back immediately when we see something bad and investigate then. So working together with how changes are introduced, working together with the development teams often actually means we can combine the infrastructure and allow the developers to move faster, which isn't as intuitive, but there's normally a lot of low-hanging fruit there as far as things that will both make the SREs and the developers happy. Some of those are progressive rollouts and all of those other things. A lot of that allows you to test on a smaller pool and confirm before, so you can release the get the release out faster. Cool. So we all want to move faster, despite common misconceptions with SRE. And the developers can move as fast as they want in our paradigm, actually. The big wall there is the error budget. And if the error budget gets hit, they have to freeze. And they have to freeze until it's recovered again. So most dev teams, this is a nice feedback loop of they prefer to take a partial hit and not fully freeze, but know that they're near the budget. Because if they never actually exceed, they don't have to stop. If they exceed, they have to stop until it's recovered again. So that if it's a bad enough outage, it may be a month until you actually can start releasing your features again, which is something nobody wants. So provisioning, having the capacity is one thing, making sure that it is obtained swiftly, and that when it is actually integrated into the system, that it doesn't break, is equally important to having it in the first place. If you have an outage because you added a new region and the system isn't expecting it, that is possibly worse than actually not having the capacity at all and just dropping the extra queries. So what we are known most for is emergency response, but surprisingly, this is actually largely training and support is responsible for our success. I've had a lot of good developers that were hesitant to try being on call try the SRE role at all, but we have this lovely program internally called Mission Control, and we'll bring them over. And the majority of them are able to do on call. A number of the most hesitant ones actually end up being the best of our SREs, which is a really exciting thing to see. And it's a matter of not panicking, making sure we have support, knowing that you're not going to be blamed if you reach out. The system is more important than your own ego. You're not going to be harmed financially for it either. So starting with the outages and the postmortems afterwards, we need to determine how bad an outage actually needs a postmortem. It's very important to be clear on consistency of incident size and a standing definition for the clarity of all parties involved on what to expect. Postmortems are probably the most vital part of our culture. Is how we learn from what's happened in the past. It's the most frustrating thing in the world to repeat outages, whether it's the exact same one or a pattern over and over again. We're here to learn more things and make it more stable. So this is one of the big scary ones, culture-wise. This is something that's hard to do. It's not easy. Our job is absolutely impossible without support of our choices, though, when we're on call. We can be handed a big system. If we're not handed the equal trust and responsibility to go with that system, then we are afraid to make the choices that are necessary to recover the system. We'll instead stick to what's documented, stick to what's we know we won't get in trouble for, as opposed to taking our knowledge of the system and doing what we need to patch it again. And this is valuable not just during the outage, but at all times, which includes during the postmortem. Unavoidably, some of our day-to-day work will be ops. That's how it goes. We are part software engineer, we are part systems engineer and ops. The important thing here, though, is that we need the support to make choices on what to automate and when, so we can take away all of these manual repetitive tasks and instead spend our time on better things. Without that, you're not going to have a system that scales. You're just going to throw more and more people into the bucket until it actually gets fixed. And the best of your people will end up bored, which Anne mentioned earlier. We have better problems to fix next year. The team skills. We like a 50-50 mix. This often means when you're converting from a traditional ops version, actually keeping all of those ops people. Almost all of them will be happy to work with you, and their knowledge is absolutely invaluable. Everybody should be able to code. We do kind of enforce that, but that is also so that the system engineers don't end up with all of the ops work. We want to be treated as equals. We want the respect to be in both ways. We don't want to bucket the work. That's not a very, that creates silos that are unnecessary. It's not very team-like. And again, we will point out that empowering the SREs is the most vital thing in the world for this. If you punish the SREs for doing their job, if you don't give them the necessary escalation tools, if you don't back them when they say this is too much, the system is going to fall over, you're going to have an outage. They are the people who know most about this, and you have put this trust in them. So, a recap of our SRE principles and some of the examples of how that comes in. And again, pulling back to DevOps with a few more examples of how we have the SRE paradigm applied to that.
Cool. So you have all that, right? So now we're going to talk about how you can get started taking some of what we've talked about use it in your organization. Oh, magic.
I got it.
Okay, so first, start with these 4 things. Start with service level objectives. SLOs are the combined agreement between the product, dev, and SRE teams. Without SLOs, you don't have error budgets. Having both of these helps prioritize the work. 2, hire system engineers who can write software. They're going to end up automating a lot of that manual work that was done traditionally by the ops team. 3, treat your product and operations or system engineering teams the same. We're all software engineers at the core. We want to have respect between the 2 teams, not have that wall that you're just throwing crap over. And then 4, we want to make sure that the SRE teams are able to choose their work. So, for example, if the error budgets continually get exceeded, and the products engineering team's not helping out, then the SRE team should be able to deprioritize support for that service. SREs are valuable and scarce, so we want to use their time wisely. So you've got this. Pick one service, pick something simple, run it through the SRE model. Make sure that your team feels empowered, that they have support from management and so forth. You check and make sure that your services are up and running. Make sure you check in with the team health, because change is hard. We all have to adjust. Things are going to fail. People are going to make mistakes through this process. That's okay. And using things like the blameless postmortems helps. It's an iterative process. But once you feel like you've kind of got this dialed in, it doesn't have to be perfect. Become the internal advocate. Take that service that you've run through the SRE model and start talking to other teams internally. You're going to find people who are excited about this, and they're going to be your people. They're going to be your internal advocate team, and you just keep talking and showing this, and you're just going to start seeing some of the SRE practices pop up in your company, and it's just going to continue to evolve. And we're here to help. So we'll talk about a few ways that you can engage with Google.
As I mentioned earlier, I am part of the customer reliability team. We help you learn how to SRE in your own team. We'll actually come in and do workshops, do meetings where we help you set SLOs, build your monitoring, build your SRE team itself. We are all SREs. We've all served on different teams at Google. So we have some background on how to get the advocacy, how to get the different structures, and of course all of the technical bits with postmortems and things like Reel of Misfortune, which is a exercise we do running through fake pages with newbies, so they're more comfortable with on-call. So, how to get a CRE is a little more interesting though, because there's not a lot of us right now. There's 20, 30 of us worldwide, somewhere in there. So you're going to contact your TAM, but you got to keep in mind your executives, your C-levels need to be behind the process, because again, we were talking about the culture support. Ultimately, if somebody is not happy, they're going to come and escalate, and they have to be supported. And interestingly, CRE is a group that you don't pay for the services, partly because of our expertise, partly because we're a scarce resource, but you do pay with your willingness and time. So we do expect you to have homework with each of the workshops. Like, we may help you build a few of the SLOs. We're going to expect the rest back. We're going to expect to see you building the metrics and showing us the graph, so we know that you're there with us and ready for the next step.
Cool. So there's also professional services, a group I'm part of. We're a paid service, but we come and we can help organizations by doing kind of intro to SRE workshops or more advanced SLO workshops. So you pick a couple services and we run through some of the SRE models and help you define those SLOs and what would happen if your error budget gets exceeded and so forth. And it also could be companies that might not meet the criteria yet for CREs. We could help with that, and then maybe eventually get people like Jess to help. So again, you can contact your sales or your TAMs, or ping us. We also have books. So we have the Site Reliability Engineering book that's been out for a little while. The workbook that's just been released. So
Yep, we've got some launch day copies over at the the 5 nines, so come visit us. We've got a bunch of the CREs there, a few SREs from other teams as well.
Cool.
And if you'd like to start reading that before you engage us, that is an opportunity to see if you are on the same page and want to execute this.
And Seeking SRE is coming soon. Thank you all.